going through same right triangle trig that you did. Okay, remember denominator missing, divide, numerator missing, multiply. If it's the angle missing, we'll do the inverse trig. Okay, so we're just going to try and apply these trig ratios in solving to real world problems. So in this first one, we are told that an 8-foot ladder leans against a building at a 32-degree angle with the ground. How far away from the building is the base of the ladder? Okay, so we've got a building that will be your vertical segment, and then the ground. Okay, the building and the ground make a 90-degree angle. Okay, and then your ladder is leaning here. Okay, so it says an 8-foot ladder, okay, is leaning against the building at a 32-degree angle with the ground. So the ladder and the ground, that is the angle that's 32 degrees. Okay, so from there, from the 32-degree angle, that's where we label opposite, adjacent, and hypotenuse. So the question is asking us to find how far away from the building is the base of the ladder. Wouldn't that be this piece here? Y'all agree? So we're looking for adjacent, and we want adjacent, and we know hypotenuse. What trig function puts adjacent and hypotenuse together? Cosine. So the habit I'm going to get in is always to write out my cosine with the variables. So theta for the angle, and then the ratio A over H. Okay, and then my second step is going to be to plug in the two of those three pieces that I know. I know 32 degrees is theta, adjacent is my unknown, and then the hypotenuse is 8. And what did that table say? When we're missing the numerator, we multiply. So we just multiply the 8 over to the other side. So then this is a simple calculator question. Remember to double check your calculators in what mode? Your calculator needs to be in degree mode. If you're going to use any of the trig buttons, sine, cosine, or tangent, in your calculator, and you're in radian mode, you're going to get the wrong answer for these. Okay, so we want to make sure under mode that degree right there is selected. So degree mode, we're doing 8 cosine of 32. I don't even have to put a multiplication there. Putting in a coefficient in front of your trig that understands that it's multiplication. So 8 times cosine of 32. And for the sake of our notes, we're just going to go to thousandths. I told y'all last week, we'll just go to thousandths unless otherwise specified. So did it specify? Oh, it does specify. Okay, so this one did specify to go to hundredths, so we'll just go to hundredths. So that's 6.78. The 4 does not round the 8 up. Okay, if you have a unit of measure, use it. What are we measuring the distance in? Feet, because it said it was an 8-foot ladder. Okay, so that distance is in feet. Now, before we get into some other problems, we need to make sure we understand a little vocabulary. Okay, so the vocabulary here is angle of elevation and angle of depression. Okay, when you have a horizontal line, okay, and you go up from that horizontal line, you're creating this angle of elevation here. I should get a different color since the background is blue. So this is the angle of elevation. Okay, so like if you're standing on the ground and you're looking up at the plane, okay, that is the angle, you're looking up, an angle of elevation, because you're elevating your sight. Does that make sense? Okay, now the pilot in the plane, if he's looking down at the ground, okay, so from his horizontal line of like where he's flying, he looks down, that is the angle of depression. So elevate is looking up, depression is looking down. Okay, elevate, rise, depress, down. Okay, now what you may remember, or what you need to remember from geometry, is the angle relationships here. So in geometry, y'all did a whole lot of work with parallel lines and a transversal, right? So if you have two parallel lines and a transversal cutting through them, you create 8 angles, okay, at these two intersections. And those 8 angles are all related to each other in one of 2 ways. Do y'all remember them? They're either supplementary, which means they add to 180, or they're congruent. Because look at so here, if they're vertical angles, that's when they're across from each other, they're congruent. Okay, and then if you remember corresponding angles, so this bottom right is going to be the same as this bottom right, or the top left will be the same as this top left. So those 4 are all congruent. Okay, and then vice versa for those that I left unmarked. Y'all agree with that? And then the 2 that are next to each other are all along a straight line, whether it's these 2, they're along the transversal, so they add to 180, or these 2 along one of these parallel lines, those are going to add to 180. So what happens there is you have these other relationships besides vertical and corresponding. You have these that are alternate interior. Y'all remember that? Or alternate exterior. So alternate interior and alternate exterior angles are also congruent. So that's the relationship between the angle of depression and the angle of elevation. Okay, these are parallel lines, and this is your transversal. So these 2 angles are congruent to each other. Does that make sense? Do y'all remember that kind of? So I'm just going to mark just those 2 in this picture. So the alternate interior angles are congruent. Okay, so angle of elevation and angle of depression are actually equal to each other the way that this is drawn. So depending on what you're given in your scenario, if it's an angle of depression and that happens to be outside your triangle, you can just label that number the angle of elevation inside your triangle. Okay, so here it says in the figure, the angle of elevation and depression are congruent, because they are alternate interior angles of parallel lines. Feel okay about that? Okay. So let's see what this next one is. It says, surveyor is standing 115 feet from the base of the Washington Monument. He measures the angle of elevation to the top of the monument to be 78.3 degrees. Okay, so here's the man. Hello. Okay, here is the Washington Monument. I didn't draw that very straight, but you get the idea. So he is standing 115 feet from the base of the monument, so the distance between the man and the monument. Okay, and he measures the angle of elevation here to the top of the building. Done that a little. So this is the angle of elevation. So it's from the horizontal up, because it's elevation, is 78.3 degrees. If it's from a horizontal down, that's your angle of depression. But here it is in this scenario. So I'm going to label from there. The actual height of the monument is my opposite. 115 is adjacent. And then that's the hypotenuse. They're asking us for how tall is the Washington Monument. So we're looking for this piece here. So that's our opposite. So we want to know opposite, and we know adjacent. What trig function would we use? Tangent. So I'm going to start with the setup. And then I'm going to input my two known values, which the angle is 78.3. Opposite is unknown and adjacent is 115. So again, it's the denominator that we know. So it's the numerator that's missing. So we just get to multiply that over. So this is 115 times tangent of, I already forgot what it is, 70 what? 0.3? Thank you. All right, so 555 point, and did it say what to round to? To hundredths again? Okay, so 555.31. And this was also measured in feet. And that's accurate. The Washington Monument is 555 feet tall. If you've never been to Washington, D.C., it's a pretty great place. I went a few years ago for a conference for school, actually, and I went to the Washington Monument. It was really neat to see in person. All right. A lighthouse is 200 yards from a bike path along the edge of a lake. So there's a bike path along the edge of a lake. And 200 yards from there is the lighthouse. A walkway from the bike path to the lighthouse is 400 yards long. Find the acute angle between the bike path and the walkway. All right, so try and give you all a visual. Okay, I'm going to put the lake up here. Okay, so this is water. This is the water's edge. So there is a walkway along the water's edge. Okay, and then the direct distance, okay, so at a perpendicular angle there, from there is the lighthouse. I'm not the best artist. What's at the top of the lighthouse? It's like the light beaming out, right? Beep, 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 beep. And they like to be striped. There's my lighthouse. Okay, so that distance is 200 yards. And then there's a walkway that's 400 yards from the walkway, or excuse me, that is a bike path, and that is a walkway. And it says the acute angle here between the bike path and the walkway. We okay with that? That's what they want us to find. That's theta. Well, from theta, this is opposite, and this is hypotenuse. I do not know the adjacent. I do not need to know the adjacent. They're asking about an angle when I know O and H. So what trig function should I use? O and H is sine. SOHCAHTOA. Sine is O over H. So this time when I plug in my two known values, they're both side lengths. If you want to reduce that, if you want to put 20 over 40 or 2 over 4 or 1 over 2, that is fine. You can reduce this as long as that ratio stays accurate. As long as you keep the proportion, you can reduce your fraction there, but you don't have to. So to find theta, what do I do when the angle's the missing piece? Inverse trig. So in this case, inverse sine. So inverse sine of our ratio, and again, you could reduce the ratio to 1/2 if you wanted, or you could leave it as 200 over 400. It doesn't matter. Okay, when you input that in the calculator, as long as the ratio is the same, you'll get the same answer. So we hit second sine to get inverse sine of 1/2, and I'll just show you entering it as 200 over 400 gets you the same thing, as long as those ratios are equal. So that is a 30-degree angle between the bike path and the walkway. So what type of triangle is that? That's a 30, 60, 90. That's one of your special right triangles. Do y'all remember your special right triangle ratios? Okay, for those that don't, I'm going to jot them here in our notes. I'll just go back up. I think we had some space up here. In this blank space is where I'll jot it just as a refresher, because I think there are a couple of practice problems on the ALEX where you would need to know your special right triangle ratios. So just as a quick review, okay, so for your 30, 60, 90, I don't know why I just drew that so tiny. Let me make that a little bigger. It doesn't matter how big you write, as long as you can read your writing. So your special right triangle ratios, who remembers what they are? X is the smallest, so that's across from the 30. The shortest side's across from the smallest angle. X square root of 3 is the which one? Good. So that's the longer leg. Good. So what you need to remember is the hypotenuse is twice as long as the short leg, and the long leg is the short leg times root 3. Those ratios to each other are true for all 30, 60, 90 triangles. And you can see that in our example we just did. The short leg and the hypotenuse is double the short leg, wasn't it? Okay. So that's going to be true for all 30, 60, 90 triangles. What's your other special right triangle? So if you have a 45, 45, 90, that means you've got an isosceles right triangle. Okay, so we can call both legs x because they're equal. What is the hypotenuse in ratio with those? X times the square root of 2. Good. Okay, so just a quick refresher, because you may need that for some of the ALEX problems. You may need to remember that from geometry. All right, so let's go back down to the last example here. It says find the length of a skateboard ramp, or excuse me, find the length of a skateboard ramp if it is 4 feet off the ground at its highest point. So here's the ground, here's the ramp, okay, and the highest point there is 4 feet. This is what we want, the length of the ramp, and it makes a 18.4 degree angle with the ground. So the ramp and the ground, that's this angle, 18.4. So from there, this is the opposite, and this is the hypotenuse. Okay, this is the adjacent, but we really don't need it. We want hypotenuse, and we know opposite, so that is sine. So we plug in our known values, which are the angle and the opposite. This time it's the denominator that's missing. What do? Yeah, those two just end up switching spots, remember? Because if you multiply the x over and then divide the trig over, so you can just switch their spots. So you are dividing 4 divided by sine of 18.4. And I didn't look. Yeah, 100th again. So this is 12.67. And this one was measured in feet as well. That is the length of the skateboard ramp. So again, find the length of the skateboard ramp. That was this piece of our triangle. All right, y'all feeling pretty good about right triangle trig? Okay. You have 2 ALEX assignments that are active and on time right now. The one that I assigned on Friday is due today before midnight. It was 7 problems. And the one that you were assigned yesterday is only 5 problems, but it's not due till tomorrow. Okay, so make sure you finish up the one that is 7 problems long, the one that's due tonight first, if you have not yet. Okay, and then you can work on the other if you have time. That one's not due till before midnight tomorrow night. All right, so y'all can have the rest of class to work on that. Don't forget to go back and finish those.